Prepare to have your assumptions turned upside down. The windswept, nearly treeless Falkland Islands were once lush, shaded forests teeming with life. It's a hard image to picture if you've only known these islands as cold, grassy stretches under vast Atlantic skies. But fresh discoveries buried beneath Stanley, a layer of dark, woody sediment, have upended the familiar story. And this is the part most people miss. The clues don't just challenge our ideas about the islands. They force us to question how easily landscapes can flip over time. Let's dig into the evidence. The finding began as construction crews uncovered what looked at first glance like an ordinary deposit. But when scientists took a closer look, they found not just random debris, but a rich layer packed with the remains of ancient plants. This hidden stratum, known as a lignitic layer, was once a soggy, low-oxygen basin, so swampy that leaves and wood barely decayed. Over the ages, that plant mush pressed into a dense, carbon-rich bed full of secrets. But here's where it gets controversial. What exactly lay buried? Dr. Zoe Thomas, rushing in with her team from the University of Southampton, salvaged samples before they dried out. She recalls, with some amazement, that the ancient tree remains looked nearly as fresh as wood washed up on a modern beach. Lab work revealed 3 key types of evidence: fossilized pollen, minute plant spores, and chunks of wood. Pollen grains and spores, remarkably robust, keep their intricate species-specific forms for millions of years if sealed away from air. These microfossils, when carefully extracted and studied, can tell us much about who grew there. In this case, the experts found southern beech, Nothofagus, alongside podocarps, types of conifers still thriving in the cool, rain-soaked forests of southern Chile and Patagonia. Intermixed were signs of plants that only flourish in eternally wet soils. The match between pollen, spores, and wood anatomy leaves little doubt. A cool, temperate forest once blanketed the site. Here's a point that could spark debate. While pollen is often blown far afield, fossil wood is much harder to misinterpret. By slicing the old wood thin and peering inside, scientists could see the tree's blueprint, the size of its cells, the layout of its vessels, confirming both type and likely home turf. The harmony between what the wood and the pollen say? That's strong evidence for an actual living forest right on the islands. But wait, when did all this happen? Radiocarbon dating can only reach back 50,000 years, far too recent. So, the team matched their fossil pollen sequence with those from South American sites whose dates are better pinned down. When the same pollen types pop up and disappear in the same order, researchers can align their timelines. In the Falklands, all signs point to the mid to late Cenozoic era. To put this in perspective, that's tens of millions of years ago, a time when global warmth allowed rainforests to spread much closer to the poles and out onto oceanic outposts. But why did the forests vanish? Here's where the story touches on the big fragility of island life. Islands are patchwork places. Species arrive in random bursts, often carried by wind, water, or wildlife. But once a tree gains a foothold, it can change everything, slowing wind, trapping water, and building a mini ecosystem. Yet nothing lasts forever. As the world cooled and ice age cycles set in, fierce winds, poor soils, and thin rainfall made it increasingly difficult for forests to hold out. The Falklands lack mountains that might have sheltered and protected the trees. Grasses, tough, fast-growing, and better adapted to open, stormy climates, claimed dominance, shaping the island's modern look. And this is the twist that should get everyone talking. Ecosystems aren't simply sorted by latitude or climate zone. Local wind, soil, elevation, and weather patterns play pivotal roles. Today's grasslands may feel eternal, but a shift in just a few factors could someday remake the islands all over again. Why does any of this old dirt matter? For one, fossil signals such as these give climate modelers a real-life checkpoint. If their simulations can recreate a cool rainforest on the Falklands under ancient conditions, they're on the right track. If not, their models are missing something critical. In a wider sense, the discovery is a reminder that what seems permanent in nature is surprisingly flexible. Even places that appear inhospitable could once have been abuzz with very different life. To sum up, deep beneath modern Stanley lies proof that the Falkland Islands once sheltered a thriving, cool, wet forest, a dramatic reversal from today's windswept openness. By matching pollen data, studying ancient wood, and reading the landscape buried in the soil, scientists have added another valuable piece to Earth's climate puzzle. But what do you think? Could landscapes as barren as the Falklands turn lush again? Or is this a cycle that can never be reversed? Is current grassland dominance really inevitable? Share your thoughts below. Let's get the debate going.